my name is Jamie and this is our math problem. Find the tangent line at x equals pi over 2 for the original problem 2y to the 3/2 power plus 3x squared y equals 4 cosine of x. So our first step is we're going to take the derivative of both sides using implicit differentiation. We take the 3/2 from the exponent and multiply it by 2. So we get 3y, and we subtract 1 from 3/2 to give us 1/2. So we have 3y to the 1/2 power. And because it's in terms of x, we must add dy, and we use the product rule for 3x squared y to give us 6xy plus 3x squared. And again, because it's in terms of x, we must put dy over dx, because the derivative of y above becomes 1, and because it's a y, we have to put dy over dx, equals, and the derivative of cosine is negative sine, and the 4 is a constant, so it just falls to negative 4 sine of x. So now we want to get the dy over dx alone, so our first thing we have to do is get 6xy to the other side. So now, since we have subtracted the negative 6xy to the other side, we have to factor out the dy over dx in this next step. And then after we factor out... So now we want to get the dy over dx alone, so our first thing we have to do is get 6xy to the other side. So now, since we have subtracted the negative 6xy to the other side, we have to factor out the dy over dx in this next step. And then after we factor out the dy over dx, we're just going to divide over the 3y to the 1/2 plus 3x squared in the denominator right here. So we get dy over dx equals negative sine of x minus 6xy all over 3y to the 1/2 plus 3x squared.
Since we're finding the tangent line at x equals pi over 2, we're going to plug in pi over 2 for x back into our original equation to find the values of y. So if you remember, our original equation was 2y to the 3/2 power plus 3x squared y equals 4 cosine of x. So if we plug in pi over 2 for x, you're going to get 2y to the 3/2 plus 3 times pi over 2 squared times y equals 4 cosine of pi over 2. If we continue to solve that, we will have 2y to the 3/2 plus 3 pi squared over 4 times y equals 0. This becomes 0 because cosine of pi over 2 is equal to 0. We're then going to factor out a y, which will then give us 2 times y to the 1/2 plus 3 pi squared divided by 3 times 0 plus 3 times pi over 2 squared. This then becomes negative 4 over 3 pi squared over 4. Clearing compound fractions, dy over dx is equal to negative 16 over 3 pi squared. So that is our slope of the tangent line. So then to write the tangent line, y is going to equal negative 16 over 3 pi squared times x minus 4 over 3 pi squared over 4. Clearing compound fractions, dy over dx is equal to negative 16 over 3 pi squared. So that is our tangent or slope of the tangent line. So then to write the tangent line, y is going to equal negative 16 over 3 pi squared times x minus pi over 2. So now we'll find the tangent line when x equals pi over 2 and y equals 9 pi to the 4th over 64. So dy over dx equals negative 4 sine of pi over 2 minus 6 times pi over 2 times 9 pi to the 4th over 64 over 64 over 3 times the square root of 9 pi to the 4th over 64 plus 3 times pi over 2 squared. Continuing to solve, we'll get dy over dx equals negative 4 minus 27 pi to the 5th over 64 over 9 pi squared over 8 plus dx equals negative 4 minus 27 pi to the 5th over 64 over 15 pi squared over 8. So what I did there is I just found a like denominator and combined it. So now we'll clear the compound fractions by multiplying by 64 over 64, which will give us dy over dx equals negative 256 minus 27 pi to the 5th over 120 pi squared. So that gave us the slope of our tangent line. So now we can write the equation. And our equation will be y minus over tangent line. So now we can write the equation. And our equation will be y minus 9 pi to the 4th over 64 equals negative 256 minus 27 pi to the 5th over 120 pi squared times x minus pi over 2. And there we go, that's the equation of that tangent line. The end.